Thank you for viewing the engine room. Please note that the mall will not be finished until later this spring, but you can experience many of the features right here.
Hi everyone, my name's Taryn Luce. I am a senior at the University of Mary Hardin-Baylor in Texas, and the video that you just saw is part of my senior exhibition project that I'm presenting in 2022. As a double major in both graphic design and computer science, I wanted to have a way to showcase my graphic design portfolio and make it stand out, while also reflecting my background in computer science. I figured, why not take my graphic design portfolio content and put it into a virtual reality environment that would feature state-of-the-art graphics and unique solutions to programming challenges. This presentation focuses primarily on the programming and technical aspects of this project. So, a bit of background on the project. The virtual environment is built on top of the Unity 3D engine. Unity is an industry standard program for developing virtual reality applications, and it includes a lot of useful VR and graphics packages, particularly the high definition render pipeline, which is a rendering configuration that I wanted to use for this project to give it a realistic appearance. Now, using Unity's high definition render pipeline proved to be a challenge because virtual reality has to maintain a consistent frame rate in order to be a comfortable experience. Otherwise it causes motion sickness. So not only did I have to implement this with the high definition render pipeline, my project proposal also included augmenting the pipeline with ray-traced reflections and global illumination for added photorealism. And if you're not familiar with ray tracing, it's a rendering technique that really gives photorealistic results by mimicking the way light behaves in the real world, bouncing virtual rays of light off of objects. And it's really good, but it's really difficult to implement because it requires a lot of processing power, especially when it's used in conjunction with virtual reality. Now, part of the solution to needing more processing power was simply to use a more powerful computer. So I actually developed this project on my university's research workstation that includes a Titan RTX graphics card. This graphics card's designed by NVIDIA, and it's designed for high-performance ray tracing and rendering. Even with that, however, I had to make optimizations in order to get a comfortable frame rate in VR. Although I could have used ray tracing for every aspect of rendering pretty much, I decided only to use it for real-time reflections and real-time global illumination to save on performance. And then I also downgraded the resolution of the ray-traced images to further increase performance. If you look at the low-quality version versus the high-quality ray trace, the low quality is a little bit fuzzier, but it's not really noticeable in VR. Now, the second part of this project involved actually writing my own code to implement features into the virtual environment. Even though the environment uses the Unity engine as sort of a foundation, I had to write a lot of code on top of it to provide features that simply weren't built in. And to help organize the code, I split these features between three manager programs. There's an audio manager, a time manager, and a weather manager. And these managers essentially control the state of the environment in real time as it's running. So the first manager is the audio manager, and it's a fairly simple program. It takes control of Unity's built-in audio playback and controls two audio sources. A music source that handles the ambient music soundtrack that you heard in the video, and then a second source for voice clips. Now for the ambient music, it's a pretty simple program. It chooses a random entry from a list of music files, and then once that entry finishes playing, it selects a new random entry and repeats the process. That way there's always automatically ambient music in the background. Voice control proved to be a little bit trickier to implement, mainly because I can't have voice clips playing repeatedly over and over, but I did want to have voice clips periodically to give information about the environment to viewers. So what I did is I actually implemented a semi-randomized timer that chooses a value in between a minimum waiting time and a maximum waiting time before selecting another voice clip from the playlist. So basically play one voice clip, wait anywhere from 20 seconds to a minute, and then play another one and repeat. That works fine for pre-recorded voice clips, but I actually wanted to take it a step further and have the audio manager dynamically read information such as current time and temperatures. So I figured out a way to actually have it read out numerical information by basically sequencing multiple audio clips into an array to create a full sentence and full words. So I used a special algorithm that parses integer number values and then selects the appropriate audio files for each number. For example, the integer 25, it would take the audio file for 20 and the audio file for 5, put them in a sequence, and then play them back in order to get the full number. Now, the time manager is actually really important to the visual appearance of the environment. As you saw in the video, the lighting in the environment is not static. In fact, it actually normally changes over a 24-hour period. The time manager synchronizes everything to time in the real world, especially a virtual sun that shines light through the interior. It sounds pretty simple to update a sun, but it's not. The time manager has to update multiple variables such as rotation, exposure, and both the lighting and sky color, all while people are viewing the environment. And I figured out the solution to this was to actually define settings for every hour of the day and store those settings into data arrays. And then I could use the current hour as an array index to select the correct settings for exposure, color, etc. Now, that would work well, except that you would see the changes jumping every time the clock changed to a new hour. So, like say it was evening, suddenly the sky would go from blue to orange with no transition. So I actually developed a mathematical function to linearly interpolate between the settings for the current hour and then the following hour to create a smooth transition that the viewer won't notice jumping. Now, the Weather Manager is still a work in progress, but it's a really cool feature that I'm excited that I've implemented. The Weather Manager, as the name suggests, keeps track of data that's related to temperature and current conditions. It does this by basically downloading every hour the 24-hour forecast to provide an approximation of the real weather. And this data can be used to actually simulate actual weather effects such as rainfall, cloud coverage, all sorts of things, as well as giving the audio manager the ability to dynamically report the weather. Now that I've constructed the virtual reality environment, the next step is to actually build a larger area with more to explore and more, of course, graphic design content. This final project will be exhibited in the spring of 2022, so I'm hoping that I get to present this completed research project one more time at Alpha Chi.